Okay, on the first two, it says, find the indicated real nth roots of A. So, another way to rewrite this is this number goes in the crack, and this number goes underneath. Now from here, we need to break down the fourth root of 81. Either A, by using your calculator, or B, 81. Does 2 go into 81? Does 3? 27 times. Does 3 go into 27? 9 times. Does 3 go into 9? And 3 goes into itself once. Therefore, I'm looking for 4 of the same. Do I have 4 of the same things? Yep. What do I have? 4, 3. So my answer is 3. Done. Okay? Number 2. Bless you. Has a 5. Bless you again. And negative 1,024. What number goes in the crack? 5. What number goes underneath? Now, on the first one, we were an even root. This time we're an odd root. When you have an odd root, you can do negatives. When there's an even number, then you can't. And that's where you have to take an eye out. But when you have an odd number in the crack and a negative number underneath the house, then that just means that your answer is going to be negative. Okay? If it was a positive underneath there, then my answer would have been positive. Now, I need to break down 1024. 1024. Does 2 go into 1024? 512. Does 2 go into 512? 256. Does 256 be divided by 2? 128. Does 2 go into 128? 64. Does 2 go into 64? 32. Does 2 go into 32? 16. Does 2 go into 16? 8. Does 2 go into 8? 4. Does 2 go into 4? 2. And 2 goes into itself one time. Now, according to the number in the crack, how many am I looking for? 5 of the same, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Hey, no leftovers. The first number I circled was a 2. The second number I circled was a 2. And 2 times 2 is? 4. So my answer is negative 4 for the whole thing. Can you handle that? Then I would have went negative 4, the fifth root of 2. If there would have been a leftover like 1, 2. Then I would have been 3. And if there was a 2 and a 3, 2 times 3 is 6. Can you handle those? Pretty easy? Good. 2 out of 15. (16 to the 3/4). Now, first thing is, I don't really necessarily care for the fraction, so I'm going to rewrite it. When you have a fractional exponent, that means radical. 4 goes in the crack. 16 goes underneath the house. 3 goes up on the exponent. Now from here, what is the fourth root of 16? If you don't know, then break it down. 2 goes in there 8 times, 2 goes in there 4 times, 2 goes in there 2 times, and 2 goes in there 1 time. I have 4 2s. So 2 goes in there. And now after that, 2 times 2 times 2 is what? 8. And done. I did it without a calculator. All I did was I rewrote it to be the fractional exponent as a radical, and then I simplified it. I'm going to do the same thing on the next one. It's 125 to the 2/3. What number goes inside the crack? 3. What number goes inside the house? And what number goes on the outside? So now 125, does 2 go into 125? No. Does 3? No. Does 5? Yes. 25 times. 5 goes into 25. 5 times. And 5 goes into itself once. Do I have 3 of the same things? I have 3 5s and nothing left over. So the 5 goes there, squared. What's 5 squared? And I'm done. What do you guys think? Can you handle that? Good. Number 4 has 2x to the 6th equals 1458. Now this goes back to how to solve basic equations. When you solve an equation, the first thing you got to get rid of is you got to get rid of any adding and subtracting. Is there any adding and subtracting in this problem? No. The second thing you got to get rid of is multiplying and dividing. Is there any multiplying and dividing in the problem? Yes. How do I get rid of it? Divide both sides by 2. That gives me x to the 6th equals 729. Third thing I get rid of, is there any exponents? How do you get rid of to the 6th? Not square root it. 6th root it. And then you 6th root the other side, because what you do to one side, you got to do to the other. The 6th root of x to the 6th is x. And then 729, the 6th root of 729. Does it come out evenly? Does 2 go into 729? No. How about 3? I think it's 243. Does 3 go into 243? I believe it's 81. Does 3 go into 81? I believe it's 27. And I think we've already seen this number. It seems like twice or 3 times. Do I have 6 of the same number? 1, 2, 3, 4, 5, 6. Any leftovers? No. Now, here's the catch. This particular answer, because we are even rooting it in an equation, it should have been plus or minus. Because I can take negative 3 times 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 negative 3 and still get 729. If you are having a even root in an equation, you got to put plus or minus. An odd root only is whatever the sign is. So if it's an odd root, then you put a plus if it's positive, minus if it's negative. But if it's an even root, plus or minus in an equation. So if there's an equal sign. Okay? Not if there's not. What do you guys think about number 4? Are you guys okay with number 4? Probably.
And it 3.04 came.
Then you typed it wrong. Trust me.
Oh, it's so close.
But it's so not right. All right, so for this particular one, is there any adding and subtracting outside of the grouping symbol? No. Is there any multiplying or dividing outside the grouping symbol? No. Is there exponents? Yes. How do I get rid of something cubed?
Oh, wait, no, I was talking about this one.
Oh. Cube root it. Now, the cube root of 28 is not user-friendly. But it is one thing, and that is it's only positive. When you cube root, 5th root, 7th root, when you odd root, you just get, if it's a positive underneath there, it's a positive. If it's a negative underneath there, it's a negative. It's not plus or minus when you odd root it. Now from here, how do you solve for x? Minus 6. Now, when you type that in, you can go negative 6 plus the 3rd root of 28, or you can go the cube root of 28 minus 6. You got to be careful where you put the minus 6 if you put it in the back, because like in Nick's calculator, for instance, if he puts the cube root of 28 first and then puts a minus 6, and if he doesn't stop it, it might do this whole thing like that, and that's not right. So when you've got an older calculator, or a newer one, you've got to hit the right arrow at this point, then once you're done, to get out of that. Or put negative 6 plus the cube root of 28, and then you won't have a problem. And maybe that's what came out as a different answer. Okay? So, when you type that in, what'd you guys get? I got negative 2.96.
I got negative 3.04. Well, that's what I did. That's what I did. Option 4. Maybe I forgot the 28. Oh, well,
Minus 6.
what I did something weird. So I solved that first and then just subtract 6. So I guess I did it wrong.
And, okay, now let's do this. 3.04 minus 6, Nick. You actually have it solved right, you just subtracted wrong. You actually, the way you have it typed in, or the way you have it typed is perfect, but you just didn't.
Oh yeah, I did that in my head. I failed.
Yeah. That's okay. Just don't do it in your head. Okay, so are you okay with ones like number 5? Number 6. Now, I helped a couple people do this one yesterday, and we got the same answer, but it was a really, really long process to get it. So I decided to make it easier for you. Now, here's the one thing that in my head, I can't stand fractions. Even though I'm a math teacher and I can do them, I'd rather prefer not. Make sense? So for this particular thing, when it's got the 4th power, that's the same as the 4th root of 48 and the 4th root of 6. Now in that section, remember when I have the same roots, I could then reduce the fraction. 48 over 6 reduces down to what number? 8. That's really ends up being the 4th root of 8 to the 6th power. Now, if I rewrite it back to fractional exponents, 8 is my base. What's the top number? Not 1. 6. This is the top number. And the bottom number is from the crack, which was 4. What is 6 over 4 reduced to? 3/2. So I got 8 to the 3/2. Now, some other people last hour asked, can it be written differently? Yes, there's other options, but that's the easiest way. Especially the base stuff. That's number 6. Number 7 has the 4th root of 3 times the 4th root of 432. Now, what do you do when you're multiplying? What can you do with the pieces? No, not add them. That's what you're confusing with that, Nick, is if they're the same base, then you add exponents. These, the exponents would be the same. So what can you do with the bases? What can you do with the 3 and the 432? Multiply them, right? So what is 3 times 432? Thank you, Nick. So 1,296 goes underneath the house. Now, from its 4th root, I'm looking for 4 of the same answer. Now, here's a little suggestion. Do you guys remember how to put 4th root in your calculator? Now, depending on the age of your calculator, if you've got an older calculator, you would type, oh, look at there, it's on the board. You would type a 4 first, then the math button, then down to option 5. And this is what it's going to write. It's not going to give you this parenthesis, but then I put the parenthesis in there, and I put 1296, and I closed it, and I hit enter. If you've got a newer calculator, do not hit the number 4 first. Just go right to math option 5, and then you get this scenario happening. And then you go and you put the 4 in there, and then you put the 1296 underneath there. What number comes out? 6. Now, if you don't know that or don't want to use the calculator, don't worry. I could have went 1296. 2 goes in there 648 times. 2 goes in there 324 times. 2 goes in there 162 times. 2 goes in there 81 times. 81 seems like a number we've seen before. I have 4 2s and I have 4 3s, and 2 times 3 is also 6. So I did it either by hand or with the calculator. I don't care how you get the answer, just get it. Okay?
So what if there wasn't 4 3s?
Then whatever I didn't circle stays underneath the house as leftovers. So let's say you only had 2 3s, right? 2 would go outside, and then the leftovers, 3 times 3 is 9. So it'd be the 4th root of 9. On 8, we have 1 over 3 plus the square root of 2. Can you have root 2 on the bottom? No. How do you get rid of it if it's a 3 plus root 2? You multiply it by its conjugate. What's the conjugate of 3 plus root 2? 3 minus root 2. And what you do on the bottom, you got to do when you're on top. So, which part do you want to multiply first, the top or the bottom? Bottom? What's 3 times 3? 9. What's 3 times negative root 2? Negative 3 root 2. What's root 2 times 3? Plus 3 root 2. And what's the square root of 2 times negative the square root of 2? What's root 2 times root 2? It ends up being negative 2 because 2 times 2 is 4, but the root 4 is 2. Now, what happens to the middle? They're gonzo. And what's 9 minus 2? 7. On the top, what's 1 times 3? And what's 1 times negative root 2? And can I combine those? Is there anything I can reduce? That's number 8. What do you think? Number 9. Has the cube root of 16 minus 5 the cube root of 2. What's the rule when it comes to adding and subtracting of radicals or square roots? They have to have what? What did you say, Devin? Same house. And right now, I've got a 16 in the front and a 2 in the back. Are those the same? No. So if they're not the same, try to make them the same. If they can't, then they can't. But if they can, you better. So 16 is the same as 2 goes in there. Two comes out because you had one group of 3 2s, and 1 2 stays behind. Nick, this goes back to the question you just asked me. This one didn't have any friends, so he has to stay inside. Now, are the houses the same? Yeah. Now the houses are the same. So therefore, if the houses are the same, then I what to the fronts? Add them or subtract them, and in this case, subtract them, right? What is 2 minus 5? Negative 3, the cube root of 2. Done. What do you think? Now, on 11, we're doing the same thing. The only difference is now we have letters involved. So when you have a one with letters and numbers. We're going to reduce down 216 first. Okay? So 216, I'm going to put over here on my scratch piece of paper. 2 goes in there, 108. 2 goes in there, 54. 2 goes in there, 27. God, 27 looks like it showed up again, Vanessa. It's weird. 3 goes in there 9 times, and 3 goes in there 3 times, and 3 goes in there once. Do I have 3 of somethings? I got 3 2s. Do I have 3 of something else? 3 3s. So if I have 3 2s and I have 3 3s, what does 2 times 3 make? 6. Now as far as the letters are concerned, I have 9 fingers showing out right now. How many groups of 3 can I make with 9? 3. Any leftovers? No. Done. Oh, did I?
Yeah.
Whoops, sorry. Okay, on 10. Sorry, I skipped that by accident. What number is in the crack? 8, which means I'm looking for 8 of the same thing. Right now I have 9 x's. How many groups of 8 can I make? 1 with 1 left over. Where's the leftover? Leftover stays inside. I have 8 y's, guys. How many groups of 8 can I make? 1. Any leftover? Nope. Between Courtney and I, we have 16 fingers. How many groups of 8 can we make if we have 16? 2. Any leftovers? No. Thanks, Courtney.
Yeah. It took me a second to figure out how much is 8.
Why is there an X on the outside and
Because the x had 9. I took away one group of 8, so that's why the 1 on the outside. The one whole group. And there was 1 left over. So it's like this. Here's this scenario. This table doesn't quite work this today, but if all 4 of them are here, it's like me saying, hey, if I want a group of 3, I'd have a group of 3 and then 1 left over. The leftover stays inside, where the other group of 3 gets to go out inside. And that's how it kind of works. Now on to 12. We got the 5th root of 32 over the 5th root of m to the 3rd. Now, can you have radicals on the bottom? No, we already talked about that today. Right now there's a 5 in the crack and you have 3 m's. In order for that to reduce, they need to match. So how many more do I need? 2. So that means that I multiply it by the 5th root of m squared. And what you do while you're on bottom, you got to do when you're on top. Now, when you multiply like that, you add exponents. What's 5 or 3 plus 2? 5. If I take the 5th root, and if I'm looking for 5 of the same thing, and I have 5 m's, how many groups of 5 can I make with 5? 1. So what happens to the house? It's gone for the bottom. Now on the top, the 5th root of 32. 2 goes in there 16 times, 2 goes in there 8 times, 2 goes in there 4 times, 2 goes in there 2 times, and 2 goes in there once. Do I have 5 of the same thing? Yeah. I have 5 deuces. They go out to play. I have 2 m's. M and M, as it were. Do I have 5 of them? If I only have 2? If I have 2, and I got to take groups of 5, can I do it? No. So then I just leave it alone. Now here's the other option. I have 2 m's on the inside and 1 m on the outside. Can I reduce those? If 2 are on the inside and 1's on the outside. No, they don't work together. It's only if they're both on the inside or both on the outside can you reduce them. So therefore, my answer. What, Josie?
How did it, like on the bottom, how did you put the 2 and with the exponent 2?
The number in the crack is a 5, and I have 3 to start with. In order for them to cancel, these fingers need to match.
Oh,
So therefore, how many more do I need? 2. That's where I came up with the m squared. Because 3 plus 2 is 5. Okay. Then the next one, 13. I got the 4th root of n to the 4th q plus 7n, the 4th root of q. Now in order to add or subtract, we just talked about it a few minutes ago, we got to have the same house. Are the houses the same? No. In the front house, I have n to the 4th, and I have a 4 in the crack, which means I'm looking for 4 of the same. Do I have 4 of the same somethings on the front? When there's a 4 in the crack here, you're looking for 4 of the same. Do you have 4 of something? Yeah, what do you got? 4 n's. So if I have 4 n's, what do I do with the one group of 4? Throw them outside. What about the q? I only have one q. Is that a group of 4? No. Stays behind. On the back. That didn't do anything because I am looking for, again, groups of 4, and I only have one thing, not a group of 4. Now here's my question. Are the houses the same? I don't even know what I just watched there. Are the houses the same? Yeah. So now if the houses are the same, then all you do is add the numbers in front of it. What's 1 plus 7? 8. And the 4th root of q. You do not add anything with the letters. You just make sure they're the same, and then you add them together. What do you think? Okay, then from here, just so that you guys are understanding this, on your test there are 15 questions. We just did ones like, we just did up to 13 of them. First 12 are very similar to what we just did. So if you can handle everything we've done so far, that's 12 out of 15 so far. Then, on 14, it says graph. F of x equals 2, the cube root of x plus 1. Identify the domain and range. How are you going to graph? Stick it in your calculator. Right. How do you get cube root on your calculator? Math button. Option 4 or 5, depending on if you want to put the 3 in the crack yourself. Now, knowing a little bit about it, because there is a cube root, that's an S curve. But there's a 1 on the outside, means I'm shifting it up 1, and a 2 multiplied on the outside, meaning the vertical stretch by 2. So therefore, I'm guessing it looks something like this. Without having to look at it on the calculator, I'm guessing it looks something in that vicinity, right?
Yep.
Those of you who graphed it, is that about close enough?
Yep.
Okay, now, the domain and range. The domain for this, remember, is all the x values that work are all the ones from left to right. Where does this go from left to right? Forever, right? So for this particular case, negative infinity to positive infinity would be just fine. Or if you put all real numbers. Either way, it's the same thing. What about the range, which means from the bottom to the top? Same thing. Here's a little clue, and I told you about it when we did this section, but you might have forgotten about it. And I said, When you have an odd root, what is the domain and range for all of them? The same, which they are negative infinity to positive infinity when it comes to an odd root. When it is an even root, like square root, fourth root, whatever, it started at 0 and then went to the right unless it got reflected or shifted. Okay? Number 15 has a picture like this, or it has that going out here. Now it says to describe the transformation of the parent function represented by the graph of g, then write the rule for g. On yours, the blue one's not there, but I put it there for a reason. Now, when it's just a half an s like that, that is not cube root, that's square root. So that blue curve that I have up there is representing the square root parent. So, how did the black one go from the blue one? It went left 1. So that's you describing left 1. That's the only description that happens. Now, as far as writing the rule, that means come up with the equation. If the original parent was the square root of x, where's left 1? How do you represent left 1 in an equation? Inside plus 1. So that would be inside plus 1. So that's the rule. Now, let me explain something to how I gave you these questions on your test. The questions on your test say, here's the first one and here's the second one. So it gives you the equations already. Then it says, describe the transformations that took place, which you told me left 1. Then it says, draw both graphs. So what's not going to happen is, what you had to do for this particular problem is you had to tell me this and this. On the test, you're going to have to do this and this. It's going to give you that part. So you just have to tell me what happened and then draw both of them. How can you draw both of them and know you got it right? Graph it in the calculator. But then as far as the transformations go, that's not new. We've done that how many times? A couple hundred? If not more? Number 16. When it's a full S curve, that's cube root. So, what happened? What, Isaac? Up 1. That's one of the transformations that took place. Let me draw the parent so that you know what it looks like. When it's an S curve, it's cube root. When it was just half of it, it's square root. Those are the only two parents that we gave you. We didn't give you any other type of numbers. I'm going to give you the equations already. You just have to tell me what transformations took place, and then you have to draw both of them. So like the up 1. Vertical stretch by 2. Left 5. You know, that type of stuff.
What is like horizontal shrinking stuff? I don't remember that.
Horizontal shrink is when you multiply it on the inside. Horizontal stretch is when you multiply it on the inside. Horizontal stretch is when you multiply it by a fraction on the inside. And horizontal shrink is when you multiply it by a whole number on the inside.
So, like, what if like the problem gives me the number 6? Would I turn it
On the inside, when you report it out, it'd be a horizontal shrink by 1/6.
Okay.
What other operator? What other thing did it do here? It also reflected over the x-axis. So we got two things that happened. Now, when you do negative on the outside, that is a reflect over the x-axis, and an up 1 means outside plus 1. So, that's what they would expect you to do on something like that. Okay? So, on your test again, they're going to ask you to do this, and then draw the graphs. On your assignment, they asked you to do this part, and then write the new rule. They're going to give you the rule. 17. That parent is the square root of x. Why did I know it was the square root of x? Because it only had part of it. So what happened from the original one like this to the new one? It went right 1, I heard. And down how far? Good. So when I write the rule, how do I write right 1? Huh? Inside the parentheses, so square root of x minus 1. How do I do down 2? Outside? Minus 2. And done. Okay? Now again, on your test tomorrow, they're going to give you the parent, and they're going to give you the new one. You have to describe what happened, and then draw both. That's what they're going to ask you to do on the test tomorrow. You have done that hundreds of times so far this semester. I think you'll be okay. 18. X equals 3y squared minus 6. And it asks you to use the graphing calculator to draw the parabola. How do I know it was a parabola for this one, by the way? One of them squared, not both. If they're both squared, it's a circle. In order to put it in the graphing calculator, what do you have to do first? Get y equals. How do I get y by itself? Add 6. That's the first thing. Get rid of any adding and subtracting. So I got x plus 6 equals 3y squared. Now, how do I get rid of the 3? Be careful. When you divide by 3, it's not x plus 2. That is not the right answer. What that person would have done is they would have done 6 divided by 3 for the front or for the back, which isn't bad, but then they didn't take x divided by 3. Not good. So what I'm suggesting that you do, leave it as x plus 6 divided by 3. Because guess why? Your calculator can handle it. As long as you type it in right. Just leave it. It's less room for error then. Now, how do I get rid of square? And when you square root inside an equation, you should get plus or minus the square root of x plus 6 divided by 3. Now, up on the board, I want to talk about this one for a second, because here it is right here, and I've done this the last 2 hours. When you type this in, depending on the age of your calculator, if you have an older calculator, this is how you'd want to type it. When you hit square root, then it automatically comes up with a parenthesis. But if it automatically comes up with a parenthesis and you close it here, then it's only taking the square root of x plus 6 and not the square root of the whole thing. So in the older ones, when it comes up with this automatically, put another one right away. Then write x minus 6, close it, divided by 3, close it. This will give you the half of the parabola that goes where it should, where it comes in here, something like this. Then you'd have to do negative the whole thing of that, and it'll give you the other one that comes down there like that. Okay? On the newer calculators, the ones that when you hit square root, it comes up with the shadow box. Right? On the new ones, that's what I call it. Does that make sense when I say shadow box, by the way? Yeah. Okay? Then, be careful. This fraction bar needs to go over top of the entire thing. But, if you type it like this, where the thing comes here and it goes shadow box, and you type x plus 6 divided by 3, that's wrong. What's the calculator going to do first? It's going to go 6 divided by 3 first and say that's x plus 2. Is that what should be in here? No. So even with the newer ones, top goes in parentheses, divided by the bottom one. And make sure that this goes over top of the whole thing. Then you'll have it right. It looks like a sideways parabola. Which way is that open? To the right. What's the vertex? I'll give you a hint. It's negative 6. Okay? And again, all I would do on the graphing calculator, you guys, is I would physically count over how far did it go. It went to the left 6. So that's a negative 6. Your calculator would have given you that. If you were to put those in your calculator, you would see it physically crosses at negative 6. Okay? Are you guys okay with that? Typing it in is going to be the hardest thing. If it's only one of them squared, it should look like a parabola. If both of them are squared, it should look like a circle. Then 19, which I'm sure everybody was waiting for because it's a word problem. Right? A jeweler is setting a stone cut in the shape of a regular octahedron. A regular octahedron is a solid with 8 equilateral triangles as faces as shown. The formula for the volume of the stone is V equals 0.47 s to the third, where s is the side length in millimeters of an edge of the stone. The volume of the stone is 161 cubic millimeters. I want to know how long each side is. So now all I did was I used the formula that they gave us in the reading. I put in the volume that they gave us in the reading, and now what am I asking you to do? Solve for S. This is identical to number 4. The only difference is it doesn't come out evenly. So how do you solve an equation? Divide by 0.47, and that is not very user-friendly. So I'm going to do a favor, and I'm just going to leave it as is. So I got 161 over 0.47 equals s to the third. How do I get rid of cube? Cube root it. Now, when I'm doing that on a calculator, I'm going to cube root that fraction. So when I do that, I go math, option 4, which gives me a 3 there. Then I put a parenthesis, 161 divided by 0.47, and then I close it, and it should spit out an answer of approximately how much? Seven. It ends up being like 6.99, depending on if you rounded first of all, right? But it's about 7. Right, good job. Now, again, we just did all of them. We did 1 through 19. On your test tomorrow, it's 1 through 15. So think about how that handled. For instance, how on this one we had 3 graphs. The test was only 2. So some of them that we had more than others, there's probably not as many of those on the test. But I can tell you that 1 through 12 is just on the test. It's like 1 through 13 on your assignment we just did. So, practice, study. Make sure that you have your formula sheet ready to go. I know you can do it. I believe in you.